If you've done any research into the world of graph databases, then you've probably noticed that recommendation engines are a really good common use case for graph. Let's dive in to see how we might build a recommendation engine for our KillrVideo project using Gremlin and DataStax Enterprise Graph. Let's talk a little bit about recommendation system basics. Now, a recommendation system falls under the category of predictive analytics. At a high level, our goal is to predict how a user will respond to an option and then recommend only favorable options. In our example, that translates to recommending movies that a user is likely to enjoy. We'll be looking at two components of this process. With predictive modeling, we will analyze the data in order to build a model that will enable us to predict how likely a user is to enjoy a particular movie. At this point, this could be an OLTP or an OLAP implementation. In the second component, we'll look at recommendation service, where we will present users with movie options that they're likely to enjoy. This will be an OLTP implementation. Here we discuss the steps we might take for a content-based predictive modeling approach. As you can see, this approach is pretty straightforward. We start by extracting movie features such as year, genre, and actors, and then use those features to find similar movies. This is all motivated by the hypothesis that users will enjoy movies similar to those that they have enjoyed in the past. So we recommend movies that are similar to the movies a user has been known to like. Now let's discuss what our strategy might be for a collaborative filtering approach. We start by extracting user features such as age, gender, and probably most importantly, movie ratings. Once we know the similarities between users, recommending a movie is pretty simple. We look at similar users and what movies they've enjoyed, and then we recommend those movies to our target user. Now let's take a look at a hybrid approach that incorporates concepts from both of the previous examples. In this case, we can use our knowledge of movie similarity and user similarity to recommend movies that meet the following two conditions. First, we want to recommend movies that are liked by users who are similar to the target user. And second, we recommend movies that are similar to the movies that our target user has already enjoyed. Let's think about some of the other considerations that go along with building a recommendation service. Depending on your use case and approach, you will either compute recommendations using a predictive model or retrieve pre-computed recommendations. In either case, you will then order your recommendations based on relevance and finally determine how many recommendations to present to the user. Here's our KillrVideo graph schema. We have 4 types of vertices: movies, users, genres, and people. They can be related to each other by different types of relationships. Users may know each other, and users can rate movies. Movies belong to genres, can have actors, directors, composers, screenwriters, and cinematographers. And of course, we have various vertex properties and one edge property in this schema. User-defined vertex IDs are underlined. We have no meta properties in this schema, but we do have one multi-valued property, and that is the production property. Please take a moment to study this schema, as it'll help you as we work through our example. So let's start to fill in some of the details of our specific approach. We're going to use the hybrid approach to predictive modeling. We will consider 2 movies similar if they share the same genre, and 2 users similar if they've both highly rated the same movie. This could be implemented as an OLAP or an OLTP solution. But if you go with OLTP approach, then you're going to want to make sure that you restrict the number of users and movies in your working set. A quick word of wisdom. You don't know how your service will perform until you've tested it at scale. Finally, we will order movies based on their popularity among similar users and display a small number of those recommendations to our target user. So how would we go about coding something like this? Well, for starters, let's find the top genre for our target user. I'll walk you through this traversal line by line. We start by finding the target user vertex. Then we look at what movies that user has rated and what genre each of those movies belongs to. Then we use the group count step basically as a score for each genre based on how many times it has appeared. Group count produces a map of key value pairs, where the key is the name of a genre and the value is the number of times that genre appeared for the movies rated by our target user. We use the order step to sort the map such that the genres with the highest score will be at the front. Then we simply select the keys, which in our case are the genre names, and unfold the list, randomly sampling one element from the top 5. In this example, our target genre happens to be kids. We didn't discuss this previously, but hopefully it's obvious that we don't want to recommend movies to our target user that they've already watched. Now, the KillrVideo project doesn't track watch history, so we're cheating a little bit here by using the rated edge. So with this traversal, we're simply looking at all the movies our target user has rated and then filtering to include only the movies of our target genre. In this example, you can see that our target user has already watched The Lion King and Aladdin, which are both movies in the kids genre. As we briefly discussed previously, the key to ensuring good performance at scale for an OLTP traversal is managing your working set. Obviously, if you have millions of users, it won't be realistic to consider all of them in a real-time recommendation service. So in this slide, we're just setting up some of the parameters of our traversal. Now for the fun part. This traversal is a little bit of a beast, but don't worry, I'm going to walk you through it. In the first 2 lines, we're grabbing movies that are rated highly by our target user and have our target genre. In the next 2 lines, we look at other users who enjoyed the movies from the previous section with some extra filtering to ensure that our target user doesn't sneak into that group. And lastly, we simply sample an arbitrary set of those users. So now our working set is made up of users who enjoyed the same movies as our target user for the specified target genre. In the next 3 lines, we gather the other movies that users liked that have our target genre. We're also filtering out movies that our target user has already watched. Now our working set is made up of movies with the target genre that have also been liked by similar users. Then it's just a matter of crunching the scores. We group the movies by their Stax score, order the underlying map by those scores, and then grab the top bunch. Whew! Staring at a wall of Gremlin like this can be daunting. There's a lot of business logic packed into this snippet of code. The key is to break it down into manageable sections like we did here. And there is certainly still room for some improvement. You could look at incorporating other user similarity factors and additional movie similarity factors. You could also modify this traversal so it helps users branch out into other genres that they might be likely to enjoy. You could consider a more sophisticated scoring system that considers movies a user disliked or possibly didn't finish watching. With all these tools and concepts in mind, I think you're ready to give it a shot for yourself, so go check out the exercise.